In the next series of videos, I am going to demonstrate another use of the law of cosines. So if you remember back on Friday, we talked about law of cosines, using the law of cosines in order to find the length of a side. This video is going to start to show you how to use the law of cosines to find a missing angle. If you take a look at the printout, the worksheet that you had to complete for Friday night, you'll see that questions numbers 1 through 12 deal with finding a missing side. Questions 13 through 24 ask you to find a missing angle. What I'd like you to do for 13 to 24 is, once you've watched these videos and you know how to do it, I want you to complete problems 13 through 24 by finding one missing angle per triangle. You can choose whichever angle you wish, but I want you to choose one angle per triangle and to solve for the missing angle. Now let me show you how you can use the law of cosines to do that. So I'm going to draw out problem 13, which is a triangle with the side given 17, 15, and 28. So this is problem 13 on your problem sheet, and the lengths of these sides are 17, 15, and 28. And I am going to determine angle A, okay, which is this angle here. Now, I'm not sure exactly whether your sheet calls this angle B or C, but I'm going to name this angle B and C like in this manner. And the question is, what is angle A? So I have side, side, side. I have the lengths of three sides of the triangle, and now I need to determine the size of angle A. Well, the first thing is, I may remember that there are three forms of the law of cosines. Each is solved for a different letter. So if you remember, we have one version of the law is c squared equals a squared plus b squared minus 2ab cosine c. We also have b squared equals a squared plus c squared minus 2ac cosine b. And we have a squared equals b squared plus c squared minus 2bc cosine a. Now, although that may seem a bit confusing, one of the things that we can do to make this a lot easier is to realize we can always rename our vertices on our triangle in any order we want to. So we always have that opportunity. Okay, so we can actually rely on only one formula if we label our vertices correctly. But in this case, I'm going to use the formula that will help us find angle A, which is going to be this last one. And the reason the last one works is because it has cosine big A in it. Okay, so big A refers to angle A. So the easy way to look at it is that if you're trying to determine angle A, you're going to use the formula that begins with a squared. If you needed to determine angle B, you'd use this formula, and if you needed to determine angle C, you'd use the formula beginning with c squared. So we know that the formula we have to use is going to be a squared equals b squared plus c squared minus 2bc cosine a. So let's go ahead and make sure first that we know how to label our sides correctly. So we know that 28 is little a. In the way I've labeled them, 17 is little c, and 15 is little b because it's opposite big B, opposite big C, and opposite big A. So now all we have to do is plug in. But this time around, we know all the little letters because we know all the side lengths, and it's the big letter we don't know. So let's go ahead and start plugging in. Well, a squared, little a squared is 28 squared, equals little b squared is 15 squared, plus 17 squared, little c squared, minus 2 times b times c times cosine a. Now notice I leave cosine a as a variable because I do not know the value of cosine a. Okay. In fact, that's what I need to solve for. I'm going to get out my calculator, and I'm going to calculate out some of these values. And so let's see what I've got for 28 squared. Let me clear things off. 28 squared is 784 equals 15 squared, well, I know that's 225. 17 squared, I should know. Let's see, remember I told you you should really all know all the squares up to 20 squared? Well, for a moment here, I'm not entirely sure. 289 minus 2 times 15 times 17. Well, let's see what that is. 2 times 15 times 17 is 510. So this is minus 510 cosine A. Not hard to solve at this point. Okay, I can solve pretty easily for cosine A. So I'll have to add 225 and 289, which I'm doing on my calculator out of sight here. That's 514. So that's 784 equals 514 minus 510 cosine A. And now I'm going to subtract 514 from both sides. And that's going to give me negative 510 cosine A on the right. And I'm going to get, well, what is 784 minus 514? That is 270, equals 270. So this is my formula up to now. Okay, and let me solve it. Notice that in order to solve it, I've got to divide both sides by negative 510. So I have 270 equals negative 510 cosine A. And I have to divide both sides by negative 510. That way, I end up with cosine A on the right, and I have to calculate what I'm going to have on the left. It's 270 divided by negative, I'll put the negative in there, 510. I don't have to put the negative in there as long as I remember the result will be negative. And I get negative 0.529411. Let me at least take it to a few decimal places. So that's negative 0.529411. But it doesn't matter anyhow, because what I'm going to do now is I want to use a calculator. I do not want to round off yet. Remember, that's the cosine of A. So in order to find A, I have to set A is equal to the inverse cosine of that number. Okay, that is going to be the inverse cosine of negative 0.529 ... So now I'm going to go ahead and I'm going to find the inverse cosine of this number. And the way I'm going to do it is I am going to put second cosine, which is inverse cosine, and then I'm going to put the answer, the last answer that was there, in. So I'm going to go second answer, or second negative sign here, which is answer, which will pop that number in, and then this is going to be my answer. So I get 121.96. I have to do this to the nearest degree. So my answer is A equals, to the nearest degree, I can say approximately, sometimes that squiggle sign means approximately, 122, right? If I round off to the nearest tenth, 121.96 rounds up to 122 degrees. And that is the correct answer. Okay, join me in the next video as I do the second problem.